Have you ever really thought about how a website actually remembers you? It's not some kind of magic, I promise. Today, we're going to crack open the digital safe where your browser stashes the keys to your online life. Let's dive in. I mean, really think about it. You log into your favorite social media site, you close the tab, you come back, maybe an hour later, and bam, you're still logged in. How in the world does that work? It feels like magic, but nope, it's just some really clever engineering at play. So here's the secret. The moment you log in, the website server hands your browser this special, let's call it a digital key. It's called an authentication token, and it's basically your passport for that session. But here's the thing. Now your browser has a really important decision to make. Where on earth does it keep this key safe? All right, so here's what we've got on tap. We're going to solve that Remember Me puzzle. Then we'll put cookies and local storage head-to-head. We'll look at their biggest flaws, check out the modern playbook for keeping things secure, and wrap it all up with the one big thing you need to remember. Okay, so we've got our digital key. Now, the browser has two main options for where to store it. And you might think, okay, who cares? But trust me, this choice is a huge deal with some pretty massive security implications. Let's try a little analogy here. Think of local storage as, well, it's kind of like a public locker at a gym. It's accessible and your JavaScript code can just walk right up and open it. A cookie, though, that's more like a secure bank deposit box. It's built from the very beginning with security as its main job. All right, analogies are great, but let's get into the nitty-gritty. Let's really break down the technical differences and see how these two stack up side by side. So this table pretty much lays it all out. Check out the transmission row for a sec. Cookies, they're sent automatically with every single request to the server. Local storage, you've got to do that manually. But honestly, the real story, the absolute game changer, is that last row, security. Local storage is basically an open book for any script on the page. But cookies, man, they can be locked down super tight. You know, at first glance, local storage seems to have a massive advantage. We're talking about 5 megabytes of space. That's a ton of room, and it's perfect for storing things like user preferences or the state of your application. And then there are cookies. Just a tiny 4 kilobytes. It sounds like a huge drawback, right? But here's the thing. For storing a small authentication token, that digital key we talked about, it's actually plenty of space. And as you're about to see, what it lacks in size, it more than makes up for in security. And that brings us to the main event, the security showdown. Because let's be real, when we're talking about something as important as a user's digital key, security isn't just a feature, it's everything. And right here, this is the Achilles heel of local storage. If an attacker manages to sneak some malicious code onto a web page you're on, they can literally just reach into that public locker, your local storage, and snatch your authentication token. It's that simple. This kind of attack has a name you've probably heard, cross-site scripting, or XSS for short. It is one of the most common and dangerous vulnerabilities out there. Basically, the attacker's script gets to run with all the same privileges as the website's own code, which means it has access to pretty much everything. So let's just cut to the chase. Local storage was designed to be easily accessible by JavaScript. That means it has exactly zero built-in protection against an XSS attack. If a website has an XSS flaw, any token you store in its local storage is, well, it's pretty much gone. But what about cookies? This is where that secure bank deposit box analogy really clicks. See, with a cookie, you can set this special little flag called HTTP only. And it's like a direct order to the browser. It says, hey browser, do not let any JavaScript on this page read or modify this cookie, period. That HTTP only flag is basically a force field. It's the ultimate shield. Even if a hacker gets their malicious script running on the page, that script is completely blocked from reading the cookie. The browser itself acts as the guard, stopping the theft dead in its tracks. And it doesn't stop there. Cookies have another powerful shield called the same site flag. This one protects you from a whole different kind of nasty attack called cross-site request forgery, or CSRF. That's a sneaky one where a bad guy on, say, evilsite.com tries to trick your browser into doing something on yourbank.com where you're already logged in. Okay, so we know the theory now. But how do we actually put all this knowledge into practice? Let's walk through the modern-day playbook for storing these digital keys the right way. All right, after looking at all of the evidence, the verdict is in and it's a knockout. When it comes to storing something as sensitive as an authentication token, the built-in security features you get with HTTP-only cookies make them the clear, hands-down winner over local storage. But wait, there's more. Modern security best practices add another really smart layer on top of this. It's called the two-token strategy. Instead of just one key, you use two. You have a short-lived access token that's only good for maybe 15 minutes. And then you have a long-lived refresh token, whose only purpose is to get you a new access token when the old one dies. And you guessed it, you store both of these in secure HTTP-only cookies. This is brilliant, because even if an attacker somehow steals an access token, it becomes useless in just a few minutes. So this all brings us to a super practical security checklist. Number 1, always use that HTTP-only flag to block scripts. Number 2, use the secure flag, which forces the cookie to only be sent over encrypted HTTPS connections. 3, use the same site flag to shut down those CSRF attacks. And here's a big one a lot of people forget. When a user logs out, don't just clear the cookie from their browser. You have to tell your server to invalidate that token to make it completely useless everywhere. Okay, we've gone through the puzzle. We've done the head-to-head comparison. We've looked at the playbook. So what's the one big final takeaway you need to walk away with? It's this. Local storage is actually pretty great for a lot of things, like saving user preferences that aren't sensitive. But when you're dealing with the keys to the kingdom, those authentication tokens that protect a user's account, the battle-tested, built-in security features of cookies make them, without a doubt, the superior choice. It's really all about using the right tool for the job. And that kind of leaves us with one last question to chew on. The secure HTTP-only cookie is a massive improvement over what we used to do. But the web is always changing, right? Security is never a one-and-done kind of thing. So it makes you wonder, as browsers evolve and privacy becomes even more critical, what's going to be the next big thing in securing our digital keys?